Under 8.7, we are expected to find an expected value for x squared. And the expected value of expected value of x squared is given by the sigma of x squared multiplied by the probability of x is equals to x. And remember, we said this part is also equals to probability of x is equals to x is the same as probability of small x. That one don't forget. At the end of the day, we should be able to recognize that we have x squared here, and in the table we must capture that. This is an example of a more general rule that the expected value of x raised to power n is sigma x raised to power n probability of x. And we're going to see this in example 11. A discrete random variable x has a probability distribution. We have x and we have p. X is equals to x. It has a probability distribution of this nature. We have a 1, 0 point, oh no, not 0 point something. We have a 1, which is 12 out of 25, 12 out of 25. We have a 2, giving us 6 out of 25, 3, giving us 4 out of 25, and we have 4 with a probability of 3 out of 25. So the question is, write down the probability distribution for x squared. The probability distribution for x squared. And listen to this. The probability of distribution of x when it is equals to x squared does not change, because all what we have to do is simply square the x, and the probability distribution of each one of them remain exactly the way it is. So the probability distribution of for x squared remains the same. So 12 out of 25, 6 out of 25, 4 out of 25, and 3 out of 25. Just note that only the x's are going to be squared. Part B of the question is write expected value of E of the expected value of x squared. The expected value of x squared. And before we can do that, I think we can continue to produce our table here so that we can capture all the values that we need. Can we first of all bring the x squared there? Let us bring the value of x squared there, so that when we have the probability of x is equals to x squared, then we can have another column of x squared multiplied by the probability of x is equals to x squared. When x is 1, then the square is 1. When x is 2, then the square is 4. When x is 3, the square is 9, and likewise. Now, what about now? We have a new column of x squared, because we have been told the expected value of x squared is sigma x squared times the probability of each and every individual in that particular column. And what exactly do we mean by that? x squared times the probability. So 1 times the probability, we get 12 out of 25. 4 times the probability, we get 4 times 6 is 24, 24 out of 25. 9 times 4, the x squared here is 9 times the probability is 36 out of 25. 16 times the probability is 48 out of 25. So the sigma of this is, or rather the sigma of all this, even if we just created another new column here and we call it the column of sigmas, 12 over 25 plus 24, you just have to add the numerators. 12 plus 24, that is 36, plus 36, 72, and this is 172 plus 48 is simply 120 out of 25. So 120, when you divide that by the sigma of x squared multiplied by the probability of x is equals to x squared is just 120 over 25, which is 4.8. And this one is the expected value of x. Please note the expected value of x squared is 4.8. I want us to just compare that with the expected value of x, even though it is not asked in the question, so that we don't confuse the two. The expected value of x, as far as it's concerned, is sigma x probability of x. And even if we were to create a column of x px, we just have this times this, which is 12 x times px, 12, which is 12 out of 25, plus 2 times 6 out of 25, which is again 12 out of 25, plus 3 times 4, 25, again 12 out of 25, plus the last one, you can already see 4 times 3 is 12 out of 25. And this is going to be 48 out of 25. And the expected value of x, which is the sigma of x, probability of x, is 48 divided by, 48 divided by 25, which is just 1.92. I have just done this so that we can easily conclude that the expected value of x is not equals to the expected value of x squared. If asked either of them, then you have to administer calculation the way you know, but don't just assume one is equals to the other. But yes, our question was asking us the expected value of x squared, which is this. This is just but further understanding why ex is not equals to ex squared. All right.